So this is the question which appeared in IES 2018 paper, question 2. So they're saying that there is a price taking consumer who is consuming two goods X and Y, and assume that consumer's budget is such that income is greater than zero and prices are both positive and finite. You're given with one utility function and you're being asked to find out the indirect utility function for this utility function and what is an indirect utility function. So let us say you start by saying that you have the function like this, u equals to xuy, which is the direct utility function, right? So this is measuring the utility directly in terms of x and y. But this cannot answer many questions. For example, it cannot answer what happens to utility if income increases, what happens to utility if prices change. So for answering those kind of questions, you need a different function. So what you do is that you find out the Marshallian demand functions, right? These are the Marshallian demand functions. Y star PM. And these Marshallian demand functions or ordinary demand functions, they are the function of prices and utility, right? They're the functions of prices and utility. And what you do is that you can now substitute these Marshallian demand functions back into the utility function, right? So what you get is the indirect utility function. This is also telling you utility, but this is telling you utility indirectly in form of prices and income. And this is telling you the maximum utility which is achievable, right? When the prices and income, let's say, are given to you this way. So, and there are certain properties of the indirect utility function. Right? See, guys, when you will be making notes, what you will have to do is you will have to make notes in such a way. One, let us say they have asked this indirect utility function. So try to know about what is an indirect utility function. Try to know something more than what is required in the question. Of course, whatever I am telling you in the answer here, you don't have to write everything there, but you need to know little more than what is required in every question. Say, it means that you should know what is an indirect utility function. Let us know one or two properties of the indirect utility function. What do you mean? Can you solve some other questions also apart from just min of xy? So you should be knowing all of those things. So whichever paper you are preparing, do it question paper wise, and also try to know little more than what is required in the question, and you make your notes around that. It'll become very useful, and you'll be curious to know many things also. Anyhow, what are the properties of the indirect utility function? The first property of the indirect utility function is that indirect utility function is non-decreasing in income. This is non-decreasing in income. So when income increases, indirect utility function, or let's say your welfare or utility increases, it will at least not fall, right? So we'll say it is non-decreasing in income. Second, when prices increase, what do you think it should happen? What should happen to your utility? It should fall. So when prices increase, indirect utility function should fall. So you should say it is decreasing or non-increasing. In prices. So when prices increase, at least your utility will not increase, that is for sure, right? Maybe it won't change, but it will not increase. So I'm just stating these properties, I'm not proving them right now. Then indirect utility function is homogeneous. of degree 0 in income and prices, right? So indirect utility function is homogeneous of degree 0 in income and prices. So let's say if your income increases, income and prices, both of them double, then utility will also double at the same time. Again, not proving this, but just stating the fact. And one more thing, that indirect utility function is quasi-convex in prices. Just an additional property, quasi-convex in prices. So indirect utility function is quasi-convex in prices. So what do you have? Like convex, right? Like convex in prices. Again, I mean, my aim is not to prove these properties mathematically here. I'm just stating these properties. So you should know कि पहली बात, अगर इनकम बढ़ेगी तो वेलफेयर बढ़ेगा, यूटिलिटी बढ़ेगी, एटलीस्ट घटेगी तो नहीं. इनकम बढ़ेगी, सॉरी प्राइसेस बढ़ेंगे तो यूटिलिटी घटेगी, एटलीस्ट बढ़ेगी तो नहीं. अगर इनकम और प्राइसेस दोनों के दोनों डबल हो जाएं तो यूटिलिटी भी डबल हो, यूटिलिटी में कोई चेंज नहीं आएगा. दिस इज व्हाट इज मेंट. सो इन केस इफ income and prices दोनों डबल हो जाते हैं, in case if both income and prices double, then there is no change in utility. No change in utility. So indirect utility function is homogeneous of degree 0 in income and prices would mean that if income and prices they both double, then there is no change in utility. If it would happen homogeneous of degree 1, then this would mean if income and prices double, then utility would also double. That is one thing. Now, for the kind of the question which is given to you, so you have what? You have this. So I'll use the different ink. Which ink I should use? I'll use this. So you have u equals to min of xy, that is given to you. So first of all, find out the Marshallian demand function. So you know that at optimum, x equals to y, right? So, and this optimum has to satisfy the budget constraint also, which is p1x plus p2y, which means p1x plus p2. In place of y, you guys can write x equals to m. So you have what? X star and y star both are equal to m upon p1 plus p2. So what you can do? You can now substitute this x star y star back in the utility function. So your utility function is min of xy. In place of min of xy, write min of x star y star, which is min of m upon p1 plus p2, comma m upon p1 plus p2, which is min of p1 plus p2. So this is what? This becomes your indirect utility function. So VMP is m upon p1 plus p2. This is the indirect utility function for this function, for the function which is given to you, right? Okay. Now let's look at the another problem which you have. Now suppose utility function of the consumer is given by uxy equals to xy. Define what is an expenditure function and derive the consumer's compensated demand function using expenditure function. Okay. So what you do right now is you have already seen what is VMP, right? Which is the indirect utility function, right? So this is going to give you some level of utility. Now, when the moment you get this function, you substitute that function substitute the values of income and prices back into the function which you have got, you will get certain number. So that number is telling you what? That number is telling you that this is the amount of utility which you will have, right? This is the amount of utility which you will have, maximum utility you can have, given these income and prices. Now what you can do is that you can also invert this VMP. And when you will invert this VMP, you will get what? You get an expenditure function, right? In terms of prices, you can invert VMP in terms of prices, sorry, in terms of income. So when you invert VMP in terms of income, what you get is sort of like an expenditure function here. Now, expenditure function tells you what? It tells you the minimum expenditure which you will have to make in order to achieve a given level of utility, let's say U bar. So expenditure function tells the minimum expenditure required to achieve a given level of utility. So we call this function as a function of prices and utility. Now, the point is that it also has certain properties. One, it tells you what? It tells you that expenditure function, when prices increase, what do you think should happen to expenditure? Right? It should also increase. So expenditure function is increasing, or you can say non-decreasing, in prices. That's one thing. And other thing is that in case if prices double, then what do you think should happen to expenditure? It should also double, right? So again, I'm just stating these properties, not proving anything and not going into much detail. So expenditure function is homogeneous of degree 1 in prices. Then you have expenditure function is concave in prices. Now, I hope you understood the meaning of homogeneous of degree 1 in prices. So when it is degree 1, it means that when prices double, expenditure also doubles, right? So this is the way, these are certain properties of the expenditure function. Now for the function which is given to you, so you're being said like this, so u equals to xy. So first of all, find out the demand functions for this. So what you do is that you can set up the Lagrange. When you set up the Lagrange, I mean, these are the normal ways you find out. This is del L by del X, del L by del Y. So I'm doing this quickly. Most of you can solve this easily. And del L by del Y, del L by del lambda is m minus p1x minus p2y equals to 0. So you divide first by second, you get this. So y equals to x p1 by p2, and you substitute it here, the third constraint. And in place of y, you guys can write x p1 by p2. So x star comes out to be m by 2 p1. So this is the Marshallian demand for good x. What about y? So you substitute, this is m by 2 p1 into P1 by P2. This thing gives you M by 2 P2. So Y star is this. So these are the Marshallian demands, guys. So what do? You substitute X star and Y star in U. So what do you get? In place of X, you write X star. In place of Y, you write Y star. So it is M by 2 P1, M by 2 P2. So VMP is M square upon 4 P1 P2. So this much is same. Uh, this much is same as the last question. We have found out the indirect utility function also like this. Now what you can do is that you can invert VMP in terms of M. So you can write this VMP as, let's say, U bar M square upon 4 P1 P2. So you write everything in terms of M square. So your income and expenditure, that means one and the same thing, because we assume that entire income is spent. So EPU comes out to be this. So you've written everything in terms of M. So it is M square equals to 4 P1 P2 U bar, or M equals to 2 root P1 P2 U bar, right? So your question is saying to find out the compensated demand function. So for that you need a different approach. That is, you will have to use Shepardslemma for this. So you'll be using Shepardslemma. So what does Shepardslemma tells you? It tells you if you differentiate the expenditure function with respect to the first goods price, you will be getting the first goods Hickson demand function. You differentiate the expenditure function with respect to the second goods price, you get the Hickson demand function for good 2. So del E by del P1 is X1 H PU P2 by P1 U bar, and del E by del P2 is X2 H PU. H means Hickson here. So it is 2 root of P1 U bar right? So this is the way you have to answer this question. Maybe I've answered this in a very lengthy fashion. You may not have time to write everything which I've written out here, but you have to prepare accordingly, in the sense that when you see a question, try to ask yourself that what is it that they are trying to judge, and try to write some sentences about each of the concept which they are trying to judge. This will really help you a lot, right? Okay, thank you very much.